Everybody, hopefully you are enjoying your holiday season thus far. In this video, I'm going to show you how you can graph a gingerbread cookie in Desmos. This will be two parts. First one is going to be lines only, and second part is going to be coloring. And coloring, I'm anticipating that to be longer than the lines part. And so if you're just here to draw lines, you're welcome to just skip part two. Um, Before we get started with the actual graphing, I recommend using a reference photo. If you want to load one, top left this plus button here. Click on image, and you'll be shown a file dialog box. Navigate to where you place your image, and load it on here. If you want to use this exact same one, I will include a link for this one in the description. I'll also have links to both Pixabay and Flickr for any images that are under the CC0 license. That just means we avoid copyright issues in the simplest terms. So once you load it, turn the opacity down. I find that 0.3 works well because it's enough to still see the picture without it getting in your way. Once that's done, let's put it in a picture called reference, because we're going to be making folders to put them in. And then we're going to make two folders. One of them is going to be for lines. And I'm just going to stick with this for part one. And let's work top to bottom. We're going to start with a circle, and I want to say right out the gates to don't get bogged down on trying to match the lines exactly. Just use this as a guide rather than say a tracing paper. So equation for a circle is x squared minus plus y squared is the Pythagorean theorem. Is equal to the radius squared, and this is looking around about 2 units wide, or 1 and 3/4 units wide. If you want to scale the image, I mean, feel free. You're welcome to just click on this guy, and then just drag it out if you want. Now, and I like to keep this is dead on in the center so that we can take advantage of symmetry. And x is okay to be at 0 because that's the axis of symmetry that we're going to be using. And for the y value, we want to move it up, and so we're going to add, say, this looks like 4 units. All right, don't get too bogged down like I'm about to do here. Our next piece here is going to be this line coming through, and we have some choices, and this looks like a square root function. If you want to limit yourself to conic sections, which I do not recommend, a hyperbola would fit this just fine. Both of these choices are good where since both of these lines stem like right out of the gates, they go vertically up and over. It'll make it easier for us to connect a half circle down below. We'll show you what I mean. Let's do y is square root We want all the x values to be negative, and so we're going to do minus x. And we're going to be moving this over by, this looks like 4 units. So we're going to move it over by 4 units. We would like to stretch this, and I think if you multiply, it gets, yes, it does. I think if you divide this, it compresses a little bit, so we'll do that. I'm picking these numbers arbitrarily, meanwhile getting bogged down in the details. Alright, this is good enough. And we're going to shift it down. This looks like 1 unit. That is good enough, I think, for what we're trying to do. And if you want to get an intersection of this one, just hover your mouse here. We're looking for the x point. Depending on what you're looking for, I'm just going to use x. X is, we want everything below that line, so we want x to be less than or equal to 0.79. That was embarrassing. All right. Next, I'm gonna go with a. Next, I'm gonna go with a half circle because that'll connect nicely here, and this looks around about 3.3-ish. Why is so normally so we solve for the y in a circle equation, and so that would be the radius squared minus x squared, and we want the bottom half of this. So we want everything on the negative solution of a square root. Let's move this over. And we'll move this. Let's calculate this. From 3.3 to 4, that is a difference of 0.7. So we want a radius of 0.7. Now we would like this to intersect at -1, and so we would move it down by -1. And I will keep everything to the right of this bottom point here. Now we can circle this back up. This line is looking fairly straight, and so this, I think, a hyperbola fits. So the way you get yourself a hyperbola, the way I tend to remember it is plus gets you an ellipse, minus gets you a hyperbola, and I think there's 2 versions of this. One of them is x squared minus y squared. I think the other one is y squared minus x squared. Yes. And so in this case, we want this one here. No, we do not. We want this one. So let's keep the blue line, and we'll delete the red line here. So when we solve for y, add x squared, take the square root, so that gives us x squared. Well, it's square root of 1 squared plus x squared. We like to align this point with this point down here, and we just use the same number. That'll be over 3.3, and we shift it down by 1. Shift it down by 1 because that's the it's not the radius. It's the size of the bounding box, or at least the vertical size of the bounding box. And so we need to subtract 1 more. I think if it's easier, we just go off of what this number here, and we add that number here. So I'm going to do minus 1 minus 1.7. And I think we want to press it horizontally by just a tad. Then we want everything to the left of this. And I don't want to prematurely call out 1.5 here. I would like to draw this line here, find out where that intersects, because it'll be roughly this point, but I prefer to use whatever the calculator spits out when we intersect it here. And this, I think we can also go with a hyperbola. This time will be slightly different. This time I think if you look at this shape here, you can see how we can use this to fit it onto this one. And so in that case, let's solve for x live here. Subtract this. Multiply I a negative across. And then we take the square root of that. Cut, square root, paste it back in. I want to leave like this just so I can see what the size of the bounding box is. I forget that there's a technical term for that. If you know what that's called, drop me in the comments. It's been at least a decade since I've done real algebra. And now I would like to move this around about here. So we're going to guesstimate this. This is looking about 3 units across, plus the 1 unit in the width from here to the center. So we subtract 1, that'll get this over here, and we subtract another 3. That'll get us somewhere around here, and let's have the stem off of, let's call this 4.5. It will scooch this over by just a tad more. Then we can stretch this. I think in this case, stretching it vertically and pressing it horizontally will give us similar results. And so I'm just going to choose to stretch this. So that we don't have to calculate. I think if we horizontally compress this, these lines will move closer to each other, and then we need to readjust. And so I would like to avoid doing that. And now you can see where this is hitting, minus 1.503. So we go 1.503. X is between that, and we could pick this number. I think we can just go off of what this number is giving us. So that'll be 3.2. We add 1, so that's 4.2. This is a positive. And now we can use the same number. And we'll put it here. This piece is mildly bothering me, and so even though yes, we can use this y intersection, we can see that in this case the line's extending over a little bit. I like that a little more than going with the actual intersection. So let's call this. This will be slightly under 2. So minus 1 point. No, I am doing something wrong here. There you go. You move closer to the bottom, the smallest adjustments will make a big difference as far as how much more circle you get. Let's finish this half. We are almost done, and this is looking like an ellipse would fit nicely here, and we're going to finish it off with the parabola. So this ellipse will be y is minus square root of, let's go, radius squared minus x squared. And this looks like it fits well. I don't want to call it too prematurely. And let's fit this around about this. I'm going to pick 2 just to start with. And also I prefer to calculate with round numbers. I'm going to scooch it over by 2 units, and then we'll move it down to, that looks like 5 3/4. Go with 4.8. It's probably a good idea to maybe stretch this a little bit. So we've hit this at 4.5. And this is 5.8. Let's see, do some quick math. That is a difference of 1 point, no. 4.5, 5 point. Wait, no, we want the difference between this point here. So that's 4.8. Gotcha. So that's a difference of 0.3. So we need to find ourselves a 0.3 difference, and I believe we can get that. Oh, yeah, that's what I thought. And then what I did, I just went for the easy possibility of stretching it by 0.3, and then we compensated for the difference. Now I need a difference between here and here, so that's 3 and 0.2. So I think this one we want to divide by 1.2, and we square that. That should align perfectly, which it does. And now we can subtract, well, just cut everything off to the left at this point. We shifted over by exactly 2 units. I want everything to the right of that. I do not plan to make the same mistake as last time by confusing an X point for a Y point. And then finally, let's finish it off with the parabola. So let's do Y is X squared. And we know where this is going to land because that is what is go off of what this point is. Let's move it over by 2. And we'll move it down by 4.8. When I add, I'm not going to do math live. It has not been serving me well today for some odd reason. So we're just going to just grab this point. Just long story short, just pick on whatever the calculator spits out. And then we'll, so now they have the centered, we can stretch it. Multiplication makes a line narrower, division makes a line wider. So we'll just go with our trusty guess and check, and let's get it to your liking. Don't let the details get bogged down. Though I say that, but yet I'm getting bogged down on the smallest numbers. That is everything to the left of 2. I would like to test something. If we just took this number and then we just made a negative, will it actually line up at 0? I'm doing something wrong here. Alright. I'll figure it out momentarily. Wait, would like to cut this off at 0. Alright, so the next piece that, like, as I said, the nice thing about having a symmetry straight down the middle is that we can just reflect everything over. We do not need our reference for the time being, and this is actually a lot easier to work with, so that we don't get conflicted with the idea that these lines won't be on top of the other. That is totally okay. Alright, so just to show you the process of mirroring everything over, and so everything that's was on this side, we're going to reflect it on that side. In the case of this one, we used to move it over by 4 units, and so we moved it to the right by 4 units. Now we will move it to the left. And instead of greater than, we make that less than, and instead of positive, we make it negative. We try to fix that. Now we repeat the process for the other lines. I still find it easier to just duplicate and then work with that. So we're going to move it over by 3.3. That's then equal to negative. And we get the side bonus of the color code, so you can see which lines are getting reflected over. So let's add 3.3. This will be negative. Flip the signs. And we repeat the process. If you accidentally end up like editing an existing equation, and you didn't mean to do it, Control Z will do a trick just fine. That's negative. Flip the signs. Also move this over the other way, and we will do the same thing. And for the one that I couldn't seem to get right a moment ago, all right. So there we have the outline. And just for simplicity, I'm not gonna decorate this. You're more than welcome to, but I think if I added in the decorations, that would take far too long. Though if you would like to see that process, let me know in the comments. And actually, you know what? I got a better idea. I'll put out a poll. I'll give it about a week or so. And I might extend it if it, you know, if it'll like say 2 people respond. Yeah. Vote. Keep an eye on that poll and vote if you want to see another video where we actually graphing the decorations. And what I'm doing right now, reason I'm choosing red for all the lines is let's see, red and green makes brown. Yes, it does. I'm gonna duplicate all these lines once, and then I'm gonna overlay green on top of them, and that should get you a brown color. If you want this brown. The other combination is blue and orange. This also get you brown, and the color theory there is if you look at a color wheel, mixing the 2 colors on the opposite ends will get you brown. And I'm beginning to think that blue and orange might end up looking better. I am somewhat liking this a lot better than the red and green getting mixed. And let's not have an extra reference, and let's mute this line. So this would be my recommendation if you want to if you actually want a brown outline. Yeah, I will but the actual graphing part is done, and so if you found this video helpful, benefited from it, yeah, please leave a like, it helps. And if you want to see more graphic tutorials like this, where I break things down step by step, and I read the equations out loud, and provide reference images and so on. Do subscribe so you don't miss out on the updates. But in the next part, I'm just straight up like spray brown across, and so. So again, hope you found this video helpful, and and uh, and have a safe, very important, like stay safe out there during the holiday season, and I will see you in the next video.